Right, today for our calculus notes, we're going to be looking at the formal definition of a limit. So we're going to have some Greek letters involved, and I don't want you to be intimidated by those or to go rushing to the counselors to drop out of calculus. I'll explain what these letters mean, and you'll be fine. So for us to say that the limit as x approaches c of f of x equals L, what we're really saying is that for each epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus c, which is less than delta, then the absolute value of f of x minus L is less than epsilon. And so a couple of things that I want you to keep in mind. I want you to think of that delta as a margin of error for your x's. And I want you to think of the epsilon as a margin of error for your y's. And what we're really saying here is that in order for you to accept that we have gotten close enough for you to say, yes, that's the value for your y. So that's my limit. We need to know how close, how precise we have to get our x to be. So it's kind of like choosing an instrument that a doctor might use. A doctor needs to know how precise he has to calibrate that instrument. That's what we're doing here. How precise does that have to be in order for the outcome that he's expecting to be guaranteed? And that's what that epsilon is. That's a margin of error that the doctor and the patient would be willing to accept. So as you look at our example, I have function f of x is equal to x squared minus 1. I'm going to be looking for delta, that margin of error for x. How close do we have to get x to be so that if we did the f of x minus 3 in absolute value, we would be within 0.2 of the actual limit, or 2/10. So in this problem, our epsilon is that 0.2, comes from this statement. How close would we have to get to our limit? Our limit then is 3, and I'm telling you that by this symbol right here. This is your limit. And then your c value, what x value are you interested in? Well, we're interested in 2. So how close to 2 would we have to get in order to guarantee that we would fall 2/10 away from our actual limit, which is 3? I'm going to use another video to continue on with this example.